Hello students, how are you? I am Dr. S.K. Das from Regional Institute of Education, Bhubaneswar. Can you recognize me? Well, once again, I am standing before you for the live interaction about an interesting chapter, Motion of your class, which is in your NCERT textbook. Well, let us see what we will learn today. At first, we learn about acceleration of an object. Then we learn about the types of acceleration, uniform acceleration. Then we will learn about non-uniform acceleration. Then we will learn positive acceleration of an object. Then we will learn negative acceleration of an object. Let us see the concept of the acceleration with this catchy question. Well, let me ask you one more question. Can you tell other parameter or the physical quantity? Physical quantity, that quantity which can be measured. So that's why it's a physical quantity. The quantity which can be measured, that is not the physical quantity. So that particular physical quantity or parameter involved in linear motion. Can you tell the other parameter? Because one parameter you have already mentioned. So that is speed, and other parameter you have already mentioned, that is velocity, but I am giving you the clue for guessing one more parameter or the physical quantity involved in linear motion. So that is rate of change of velocity. Very nice, students. So your guesswork is absolutely correct. Rate of change of velocity. So what is, first of all, whenever you study about rate of change of velocity, let us first see what is change in velocity. So what is the change in velocity of an object moving in a straight line path? Why straight line path? Because in this class we are studying the linear motion of the object. That's why the object is moving in a straight line path, and we need to find out the change in velocity of the object which is moving in the linear motion. You have seen two types of motion. One is linear motion, where the velocity is also uniform or the constant, and the other one is non-uniform motion, where the velocity of the object is non-uniform or variable. Well, in the uniform motion, the velocity of an object remains constant. We have already discussed that. It is constant with time. That means the velocity of the car, if it is 20 km per hour in a fixed direction, that remains constant after 10 minutes even, after 20 minutes even. So then the velocity of the car is said to be uniform, and the motion is also uniform. So therefore, in a uniform motion, the velocity of an object remains constant with time, for which the change in velocity must be equal to 0. What is change in velocity? Difference between the final velocity and the initial velocity. So here final velocity is equal to the initial velocity. So difference between final velocity and initial velocity must be equal to 0. That's why change in velocity is 0. So therefore, in a uniform motion, the velocity of an object remains constant with time, for which the change in velocity is 0. Well, let us see what is the value, what is its value in case of non-uniform motion. So the velocity is varying, velocity is changing. If velocity is changing, then obviously the change in velocity, difference between final velocity and the initial velocity, is it equal to 0? No, not at all. It is not equal to 0. So therefore, you see, in non-uniform motion, the velocity of the object changes with time, for which the change in velocity is not equal to 0. So this is about the change in velocity. Then if you know change in velocity, then how can we express the rate of change of velocity of an object? That's very important, because I have already given the questions. Just guess the parameter of the physical quantity which is involved in the linear motion, and your guesswork was very proper, rate of change of velocity. Now you know about the change in velocity. Then after knowing about change in velocity, now let us see how we can express the rate of change of velocity of an object. Can you think about it? Well, the rate of change of velocity of an object can be expressed by the physical quantity which is known as acceleration. Students, I have already explained about the meaning of the physical quantity. Physical quantity is that quantity which can be measured. That's why distance is a physical quantity, time is a physical quantity, speed is a physical quantity, velocity is a physical quantity, and here acceleration is also a physical quantity. Therefore, the rate of change of velocity of an object can be expressed by the physical quantity known as acceleration. Beautiful term, no? So then let us define the term acceleration. What is acceleration? Well, we know about rate of change of velocity, but let us define that in a proper form. Acceleration is the rate of change of velocity of an object per unit time. So therefore, acceleration is equal to change in velocity divided by time taken. So it is denoted by the symbol a, small a. So the SI unit of acceleration is meter per second square. What is the CGS unit of acceleration? Can you tell that? Well, the CGS unit of acceleration is centimeter per second square. So then let us move towards the expression of acceleration. We need to express the acceleration. Although you know acceleration is the rate of change of velocity per unit time, so how do you express acceleration? If velocity of an object changes from an initial value u, I have already told you, u is the initial velocity, to its final value v, v is the final velocity, in time t, then the acceleration of the object is a equal to v minus u whole divided by t. So this is the expression for the acceleration. A is the acceleration, v minus u is the change in velocity, t is the time. So rate of change of velocity is equal to v minus u whole divided by t. So this is the expression for acceleration. And you know acceleration is a vector quantity, and I have already explained what is meant by vector quantity. Vector quantity is that physical quantity which can be described completely by the help of its magnitude as well as the direction. But what is the direction of acceleration in this case? The acceleration can be given its direction in the direction of the change in velocity. Therefore, it is mentioned that acceleration is a vector quantity whose direction is the direction of the change in velocity. If you know the direction of the change in velocity, that direction gives the direction of the acceleration. Then I am just giving another question in your mind for guessing. So can you guess in which case the acceleration is positive or negative? Very important thing, very nice thing. You just guess. The equation of the acceleration is in front of you. A equal to v minus u whole divided by t. You know v equal to final velocity, u equal to initial velocity of the object, t is the time taken. So in this case, if you see, if final velocity of the object v is greater than the initial velocity of the object u, then certainly the velocity increases. Am I right? Or velocity decreases? No, velocity should increase. If the velocity increases, that is final velocity is greater than the initial velocity, then acceleration is said to be positive. Am I right, students? A is equal to positive. Well, in which situation the acceleration is negative? If final velocity v is less than the initial velocity u, that means velocity decreases. Final velocity less than the initial velocity, that means the velocity decreases, then in that case the acceleration is negative. Am I right, students? Very interesting. And not only in this form, mathematical form, you can see all these things in your daily life experiences. Well, now I am asking you a question from your daily life experience. So can you give some example? Can you cite some example which you have faced in your daily life experience where the acceleration is positive and where the acceleration is negative? Can you answer this question? Yes, students, you are very hardworking and very intelligent, and you have marked this particular kind of concept in your everyday life experiences. So you must be traveling by train. So how do you travel by train? You go to the platform of a station and wait for the train, and the train must be approaching towards platform, and sometimes the train will be staying in the platform, then it will leave the platform after some time, maybe 10 minutes after. Then you must have marked the velocity of the train whenever it is approaching towards the platform and whenever it is leaving the platform. So please see this picture. A train is approaching the platform. So what you see? The velocity of train is increasing or decreasing? Increasing or decreasing? Because the train has to stop in the platform and you have to go inside the train. That's why the velocity of the train must be decreasing. So here, that is the picture I am just showing you. The train is approaching the platform with decreasing velocity. Then you see one more picture. What do you see? The train is leaving the platform. That means you have already entered into the train. Now train is ready to leave the platform. Then what happened? Then the train is leaving the platform and gradually its velocity is increasing. So whenever it is approaching, the velocity of train is decreasing. Whenever it leaving the platform, the velocity of train is decreasing. Well, now what would be your observation? Whether the oscillation in this case positive or negative? Final velocity is less than the initial velocity. Final velocity means whenever the train will stop in the platform of the railway station. And the final velocity should be 0 at the last. It will be decreasing and finally it will be 0. But whenever it will be coming from a distance, its speed must be increasing. That's the final velocity is always less than the initial velocity. And as I have already mentioned, if v is less than u, oscillation is positive or negative? Nice answer, students. It is negative. That's what it is mentioned here. When train enters the platform, its velocity decreases and oscillation is negative. On the other hand, whenever the train leaves the platform, its velocity increases. Since its velocity increases, final velocity v is greater than the initial velocity u. Therefore, the oscillation is positive. Very nice example. Are you enjoying, no? In one case, the oscillation is positive, other case oscillation negative. But students, one thing I will tell you, this negative oscillation is known as the retardation. Then, what are the types of oscillation? Because we have studied the types of velocity, we have studied the types of speed, two types of velocity, uniform velocity, non-uniform velocity, types of speed, uniform speed, non-uniform speed. Similarly, what are the types of oscillation? Two types. Uniform oscillation in favor of uniform motion, non-uniform oscillation in favor of the non-uniform motion. Am I right? Well, it is very simple to understand, to remember and to observe in your daily life experiences. Now, I am just giving you this situation. The oscillation of object is uniform or non-uniform, you have to identify. Now see this situation. When the velocity of the object changes by an equal amount in equal intervals of time, then the oscillation is said to be uniform or constant. You please recall the previous knowledge of uniform velocity and uniform speed. Then make a kind of comparison to understand this concept of uniform oscillation. When the velocity of the object, here there is rate of change of velocity, but when the velocity of the object changes by an equal amount in equal intervals of time, then the oscillation is said to be uniform or constant. Then give your example from the daily life experience of this uniform oscillated motion. Now see this picture. What is this? In this picture, an object is falling freely under the action of gravity. I have shown this picture in my previous class. Then, what do you observe here? The motion of a freely falling object under the action of gravity with uniform oscillation of 9.8 meter per second square. And this value 9.8 meter per second square is known as the acceleration due to gravity. You will read about acceleration due to gravity in the next class. Now see one more picture. A cyclist coming down the slope of a road without paddling with uniform oscillated motion. Uniform oscillated motion means the oscillation must be constant. Here, the freely falling object under the action of gravity, it is the case where the oscillation of the object is 9.8 meter per second square, which is the constant. That's why this is the uniform oscillated motion. Here you see the cyclist also coming down with constant oscillation. So this is an example of uniform oscillated motion. Then let us see one more picture. What do you see here? A ball is rolling down an inclined plane. This is also an example of uniform oscillated motion. I have already mentioned your observations here. Velocity of freely falling object, cyclist coming down the slope of a road, and rolling ball on the inclined plane changes by an equal amount in equal intervals of time. But I have a big question to you all. But how? Students, in science, unless until we are curious and you are curious and never ask the question why, how, then your study is not complete. That's why, students, I always request you, whenever you study science, always you ask the question why and how and what. These are the three important aspects of studying science. So now, how? How the motion of these three objects, freely falling object, cyclist, and the rolling ball, is said to be uniform oscillated motion. Why and how? In this case, the motion takes place by the action of the gravity. I have already mentioned. Gravity is pulling everything. You must be observing that whenever his body is falling freely, it is falling under the action of gravity. Whenever it is falling under the action of gravity, then the oscillation of the object must be A equal to G. G is the oscillation due to gravity, symbol of oscillation due to gravity, equal to 9.8 meter per second square. As I told you, you will study this concept in the next chapter under gravitation of your class. Well, you see this calculation. Velocity V equal to AT. Why? Because A equal to V by T. A is oscillation, rate of change of velocity. Therefore, V equal to AT. So here is the A. A is the oscillation due to gravity G. That's why I am replacing A with G equal to GT, where G is the oscillation due to gravity. And for time 1 second, suppose I allow the ball to fall freely, then in time 1 second, if t is equal to 1 second, substitute t in that equation, b equal to gt, then v velocity equal to only g equal to 9.8 meter per second, because meter per second square into second, then it would be 9.8 meter per second. Then for t equal to 2 second, velocity equal to 2 into g equal to 2 into 9.8 equal to 19.6 meter per second. For t is equal to 3 second, velocity is equal to 3g equal to 3 into 9.8 equal to 29.4 meter per second. For t is equal to 4 second, velocity is equal to 4g equal to 4 into 9.8 equal to 39.2 meter per second. For t equal to 5 second, velocity is equal to 5g, 5 into 9.8 equal to 49 meter per second. So what do you observe from this calculation? There is equal change in velocity. Is it no? You see the difference of velocity. There is equal change in velocity of 9.8 meter per second in equal interval of time of 1 second. So during 1 second time interval, there is equal change in velocity. So what do you conclude from this statement? Then the oscillation must be uniform. Then the oscillation, if it is uniform or constant, then we can say the motion of all these objects, freely falling object, then cyclist rolling on the inclined plane, the ball rolling on the inclined plane, they are, moving under the action of gravity. That's why motion of all these objects is said to be uniform oscillated motion. Are you enjoying, students? No? Very application oriented concepts and calculations. Similarly, you will do more calculations and more activities and more observations. You must be enjoying the topic. Now, can you guess in which situation the acceleration of an object is said to be non-uniform? You have already experienced about the uniform accelerated motion. Freely falling object, rolling of a ball on an inclined plane. These are the examples of uniform accelerated motion. But I am giving you to guess where you will find non-uniform accelerated motion. Can you guess that? Well, you must be coming to a school by your bicycle, no? Well, so before coming to that situation of bicycle, first of all see the definition of this non-uniform accelerated motion. If the velocity of an object increases or decreases by an unequal amount in equal intervals of time, then the acceleration of the object will be non-uniform. I have already given the example of uniform accelerated motion and also the definition of uniform accelerated motion, where you have seen in the uniform accelerated motion there is equal amount of velocity change in equal intervals of time. But here the situation is just reverse. If the velocity of an object increases or decreases or changes by an unequal amount in equal intervals of time, then the acceleration of object is said to be non-uniform. Guess the daily life experience. I was just talking about the bicycle, no? You must be enjoying the bicycle riding. And bicycles are mostly used by you people all while going to the school. But do you know, students, cycling is the best exercise for all of us. Everybody should go for the cycling. It's the best exercise, both for boys, both for girls, and also women and men. It's the best exercise. Well, so let us come to the contest. So when you come to the school in a crowded road, you recoil your daily life experience. The road must be a crowded road. Then the velocity of your bicycle must be changing, no? Sometimes the velocity increasing, sometimes the velocity must be decreasing. Okay? So by an unequal amount, sometimes it is the change in velocity, change in velocity must be unequal amount in equal intervals of time. So in such situation, the oscillation is said to be non-uniform. So that is the burning example of non-uniform accelerated motion. And these are many in our everyday life. So this is a task to you all students. I'm just giving you the activity. Just take the notebook and observe from your daily life experiences and list out the situations of the non-uniform accelerated motion from your, everyday life experience. So this is a task and you do it sincerely. Well, students, so let us discuss about these concepts, whatever you have learnt, with the help of some interactive questions. So see the first question. An object moves upward in an inclined plane whose velocity changes from 15 centimeter per second to 10 centimeter per second in 2-second time. What is the acceleration of the object on the inclined plane? Just now I was citing the example of the ball rolling down on an inclined plane. But here the object is moving upward on the inclined plane. So see, the velocity change takes place from 15 centimeter per second to 10 centimeter per second in 2-second time interval. So what is the acceleration of the object in this case? Well, I have mentioned initial velocity u equal to 15 centimeter per second, final velocity v equal to 10 centimeter per second, time t is equal to 2 seconds. So acceleration a, you know, its expression is equal to v minus u, that is the change in velocity, divided by time taken t. You substitute the value of v and u, then t, then you see the expression for a. A equal to 10 minus 15 whole divided by 2. A equal to, if you calculate this, minus 2.5 centimeter per second. Why? Because the final velocity v less than the initial velocity u. Final velocity is 10 meter per second, which is less than the initial velocity u, that is 15 meter per second. That's why the oscillation is negative. So here the negative oscillation is retardation. I have already explained whenever I was, explain you the negative oscillation whenever the train was approaching toward the platform and you are waiting for the train on the platform, floor of the platform. Well, let us go to the next question. If your bicycle attains the velocity of 200 meter per second in 20 seconds, after you start from your home on a way to the school, what will be the acceleration of your bicycle? You are coming by the bicycle. Very nice. Velocity, I mean, whenever you start your home, 200 meter per second in 20 seconds after you start from the rest, after you start from your home on the way to the school, then what will be your acceleration? Here initial velocity is equal to 0 because you are starting the bicycle. Initial velocity must be equal to 0. Final velocity v equal to 200 meter per second. Time taken 20 seconds. Definition of acceleration, A equal to rate of change of velocity, change in velocity by time taken, equal to v minus u by t. Substitute the value of u, v, substitute the value of u and t. Then see, 200 is the v and u is equal to 0. So 200 minus 0 whole divided by t equal to 20 second equal to 10 meter per second. Here acceleration is positive. A is positive because velocity increases. Here velocity never decreases. Since velocity increases, that's why acceleration is positive. You see one more question. A motor car moves 1/3 part of total distance with a velocity v1 equal to 10 kph. What is kph? Kilometer per hour. Second 1/3 part, okay, with velocity v2 equal to 20 kph, 20 kilometer per hour. And rest 1/3 part with velocity v3 is equal to 60 kph. So what is the average velocity of the car? Here the velocity is variable. So therefore it's non-uniform velocity. So in the case of non-uniform velocity, we need to find the average velocity. So what would be its solution? Can you solve this question? I have shown this, question in the diagram form. Then you solve these questions. What is your solution? Let the magnitude of the total displacement of the car say equal to x. I have shown in the diagram. For first 1/3 displacement of x by 3, the time taken is t1 is equal to, v equal to s by t, velocity is equal to displacement by time, and time is equal to displacement divided by velocity. So here for first 1/3 displacement x by 3, the time taken is t1 equal to x by 3 divided by v1 equal to x by 3 v1 equal to x divided by, substitute the value of v1, 3 into 10 kph. You convert this kph into kilometer per hour divide it, multiply 10 into 3 equal to 30, x divided by 30 hours. Then second 1/3 displacement x by 3, the time taken is t2. In the same way you can go for calculation and see t2 will be equal to x by 60 hours. Similarly for third 1/3 displacement x by 3, t3 is equal to x by 3 whole divided by v3 equal to x whole divided by 180 hours. Now what is the average velocity? You know the definition of average velocity. Average velocity is equal to total displacement by total time taken. So what is the total displacement? X. What is the total time taken? t1 plus t2 plus t3. So v average equal to x whole divided by t1 plus t2 plus t3. X divided by, now you substitute the value of t1, t2, t3, whatever you have calculated just now, then it would be equal to x whole divided by x by 30 plus x by 60 plus x by 180 is equal to x whole divided by x whole into 6 plus 3 plus 1 divided by 180 is equal to 180 divided by 10 is equal to 18 kph, 18 kilometer per hour. What is this? Average velocity of the car. Then let us see the fourth questions. A 200 meter long train crosses 400 meter river bridge with a velocity of 24 kph. You must be, traveling by the train over a river bridge, no? So let's say the length of the train is 200 meter and length of the bridge is 400 meter. Now train is crossing the bridge with a velocity of 24 kilometer per hour. What is the time taken by the train to cross the bridge? So go for its solution. I think now you will be able to solve it. Displacement, magnitude of displacement, S is equal to 400 meter because that is the length of the bridge, divided by, so 1000 because I am converting this meter into kilometer. So 400 divided by 1000 kilometer equal to 4 by 10 kilometer. Then the velocity of the train v equal to 24 kph. Then time taken to cross the bridge t equal to s by v, because v is equal to s by t, t is equal to s by v. Now substitute the value of s, substitute the value of v. So whenever you substitute the value of s and substitute the value of v and convert the time t from minute to from hour to minute, then it will be t equal to 1 minute. See the fifth questions. So in this question, a bus is moving with a velocity 60 km per hour, and driver sees a child running across the road. Then the driver of the bus applies the brake to stop the bus, because the child is crossing the road. By chance accident would be there. That's why the driver of the bus wanted to stop the bus. Then driver applies the brake of the bus. Now how much distance would be the bus moved before the driver could press the brake? Here, very important thing you have to understand, and I have asked you in the former question. Do you know about the reaction time of an average person? You must not be knowing. Now you understand this concept. The average time taken by a normal person to react to the emergency is known as the reaction time, which is about 1/15th of a second. So this is our biological organs, eyes, ears. All these organs are biological organs. We are human beings. So that's why, so our organs need to respond properly. So whenever the bus driver sees that child and wanted to give the brake, then there must be some reaction time, so that the organ need to be activated, and it will take its own time. That is the reaction time. What is that time? I have already mentioned. The average time taken by the normal person to react to an emergency is known as reaction time, which is about 1/15th of a second. Well, let us go for its solution. In this question, velocity of the bus v equal to 60 kph, kilometer per hour. So convert kilometer per hour into meter per second, and I have already told in the last class 1 kph is equal to 5 by 18 meter per second. Now if you convert it into meter per second, so v equal to 50 by 3 meter per second. Here, what is the reaction time? I have already explained. 1 by 15th of a second. 1 by 15th of a second. So distance travelled by the bus before applying the brake, s is equal to the distance is equal to velocity into reaction time. So that is the distance travelled by the bus before applying the brake. So s is equal to, substitute the value of velocity here, 50 by 3 into reaction time, 1 by 15 second. So it is, if you go for calculation, it is equal to 10 by 9 meter, equal to 1.1 meter. Well students, I think you have understood the concept with the help of these questions. Are these questions are very much interesting, no? Well, you must have enjoyed these questions and solve many more questions. Then let us see what we have learned today. We learned about acceleration. It is the change in velocity of an object per unit time. Then we learned about positive acceleration. If the velocity of an object increases, the acceleration is said to be positive. What is negative acceleration? If the velocity of an object decreases, the acceleration is said to be negative. We learned about negative acceleration. Then we learned about uniform acceleration. What is uniform acceleration? An object is said to be uniform, said to be moving with uniform accelerated motion or with uniform acceleration if there is an equal change in velocity in equal intervals of time. Then we learnt about non-uniform acceleration. An object is said to be moving with non-uniform acceleration if there is unequal change in velocity in equal intervals of time. So all these learning points we have, studied in detail with the questions, and you must have enjoyed these learning points and enjoyed the questions and enjoyed the activities. So please, you do many more activities, do many more questions and solve many more problems. Then you do something so that you can come out with a with a good result, so that you will give a great service to our nation, so that our people will be benefited out of your knowledge. So thank you so much for your participation in this class. Thank you.